You divide it into two groups of 2. Looking at just this part right here, does this part right here have a GCF? What divides 18 and 21? And they both have an x squared or higher. When I take the 3x squared out, comes around in front, 18 divided by 3 is how much? And x to the third divided by x squared cancels out all but one of those. 21 divided by 3 is, and the x squareds cancel each other out. What divides 6 and 7? 1. If this sign right here is negative, you need to factor out a negative 1. So I factor out a negative 1. Negative 6 divided by 1 is 6, and it has an x. Negative 7 divided by negative 1 is positive 7. When you get to this step right here, do you see a factor that's down there 2 times, a common factor? And the other factor is 3x squared minus 1. Where did this come from? There's the 3x squared. There's the minus 1. If I took this problem and did a box problem, multiplied it out, I would have the original problem back. That's the kind of problem we did yesterday. Now, look at the kind of problem that we are going to work on today. So, looking at this problem, how is this problem different from the ones that we did yesterday? 1, 2, 3 terms. This is a trinomial. Were the ones that we did yesterday trinomials? The ones we did yesterday had 4 terms. This one has 3 terms. So, what are we going to do? Well, it tells me. First, I'm going to factor out a GCF, greatest common factor. Does this have a greatest common factor? We do not factor out a negative unless the leading coefficient is negative. And so we would not factor out a GCF. Now, what's this talking about A, B's, and C's? This right here is standard form for a quadratic. The A is the number in front of the x squared. What number is in front of the x squared? The A is not 2x squared. It's 2. The A is a number. It is a coefficient. It does not include the x squared. B is the number in front of the x. I don't see a number in front of the x. If there's not a number in front of the x, that would make the B 1, but in this case, because of the negative sign, the B would be negative 1. What's the C? So, this first couple of steps are going to seem kind of strange. But hopefully, when you get down to step number 4, you will see why we are doing step 2 and 3. So, it says multiply the first and the last term together. We're going to multiply the A number times the C number. And that will be negative 42. So now we're going to think of the factors of negative 42. What do you multiply together to get negative 42? Nope, I'm starting at the beginning. I think I told you this the other day, I am going to go through and write down all of the factors so I don't miss any. Negative 1 times 42. Negative 2 times 21. Negative, does 3 go into 42? Well, the way you would figure that out, you'd pick up your little calculator and divide 42 divided by 3. Does it go evenly? Does 4 go into it? You take your little calculator and do 42 divided by 4, and you don't come out with a whole number. 5 doesn't go into it. Does 6 go into it? 6 times 7. But that's the same thing, only turned around backwards. So I would have some more factors, but it would be the same thing, only turned around backwards. Now, those are the factors. I need to find the factors that add together to get me a negative 1. Which of these factors could add together to equal a negative 1? Those factors add together to equal negative 1. So I am going to write down my original equation. This is my original equation that I started with at the top of the page. In place of this negative 1, I am going to write negative 7x plus 6x. Does that equal to the negative 1? I replaced this negative 1 with these two terms that are equal to negative 1. I still have the negative 21 out on the back. I still have the 2x squared, that's a negative sign, out in the front. These two equations are equal to each other. Well, why did I do that? Why did I replace the negative 1 with a negative 7 plus 6? They're equal to each other, but why? Well, if it has 4 terms, do we know how to factor it? I changed it from a trinomial to a polynomial with 4 terms. That is the whole purpose of steps 2 and 3. So now I have 4 terms. Now it is exactly like what I was doing yesterday. I make 2 groups of 2. What divides 2 and 7? Just 1 or 1x. And so what divides 6 and 21? This x that I factor out in front leaves me 2x. It's going to cancel one of those. It's going to cancel that one. When I factor this 3 out of the 6, 6 divided by 3 is 2. 21 divided by 3 is 7. Do we see a common term? What's written down there twice? And this is x plus 3. Where did the x plus 3 come from? Yes. This is the final answer. Now, you should have about an inch left down there at the bottom of your page. And so in that margin down there at the bottom of your page, we are going to check this one. X and plus 3. The first term, the second term. 2x squared minus 7x plus 6x minus 21. If I combine like terms, these terms right here, the like terms. And so you'd have 2x squared minus 1x minus 21. Is that equal to what we started with? Do you see that this right here is what we had on this step number 5? Steps numbers 2 and 3 are to figure out the numbers that we need here to make this into 2 groups of 2 so that when I factor them, I'll have a common binomial there. This is not easy. It's easier if you know your multiplication facts. Let's look at another example. Is there a GCF with 3, 10, and negative 8? A is the number in front of the x squared. What number would that be? B is the number in front of the x. What number is that? And C is the number without an x. So, first you figure out your A, B's, and C's so that you can multiply the A times the C. So, what is A times C? A times C is 3 times negative 8, which would be negative 24. Now, when I do this, I write down all of the factors of negative 24 so I don't miss the one I need. I don't just skip around. I like to do things in an orderly way. So, negative 1 times 24. Negative 2 times 12. Negative 3 times 8. Negative 4 times 6. And then they're going to start repeating 6 times 4, 8 times 3. Okay, so I need the pair that adds up to give me negative 10. Well, 4 and 6 add up to equal 10, but does negative 4 and positive 6 add up to equal 10? Nope. The signs have to work out right. And so these add together to equal positive 10. But I need negative 10. So if I change the signs around on this one, does this now add up to equal negative 10? And if I multiply them together, they add up, multiply together to get negative 24. That's what I need. They need to multiply to equal negative 24 and add to equal negative 10. So that when I get to step number 6 down there at the bottom, I will have a common binomial. This is the original problem. In place of this term right here, the negative 10, I am going to replace it with 2x minus 12x. That replaces the 10. Because it's equal to the negative 10. X. I still have the 8. I still have the 3x squared in the front. The reason I did all of this is so that I can make 2 groups of 2. Look at the first group. 3 and 2. What's going to factor out of 3 and 2? Well, 3 and 2, I just have 1, but you did notice that they both have x's, so I'm going to factor an x out of there. What divides into 12 and 8? But if this is negative, this needs to be negative. Okay, so now I am going to factor that out. The x is going to come out in front. If I divide that by an x, I have 3x left. If I divide that by an x, the x cancel. I'm going to factor out a negative 4. 12 divided by 4 is 3. negative 8 divided by negative 4 is positive 2. What do you see twice? 3x plus 2x minus 4. The x minus 4 comes from there. From step number 5 down, it's doing exactly like we were doing yesterday. Steps 1, 2, 3, and 4 are getting it into the form just like we were using yesterday. So, let's practice again. Practice makes permanent. Did you know that? Practice does not make perfect, because if you practice wrong, you won't be perfect. So, does it have a GCF? We finally have one with a GCF. It has a GCF of 2. The first thing we're going to do is factor out a 2. After you factor out the 2, look at this one right here to write down your A, B's, and C's. Looking at this one right here, what is your A? And your B? And your C? Multiply the A times the C, the first times the last one, and you will get 12. Think of the factors of 12. Like I said, I always start at the same place. 1 times 12. 2 times 6. 3 times 4. What is going to add together to get B that's 13? So I would use this pair right here. So the 2 parentheses 3x squared plus 13x plus 4, just rolled my pencil, in place of that, that is equal to 1x plus 12x. That takes the place of the 13. I still have the plus 4. I still have the 2 in front. I still have the 3x squared in front. The 2 is just going to hang around in front for the whole problem. So, the 3x squared plus 1x plus 12x plus 4 now has 4 terms, so I can make 2 groups of 2. What's going to factor out of this group? What's going to factor out of this group? You are right. I was about to write the wrong number down. This 2 is just going to hang around out in front. When I factor an x out of that, I would have 3x plus 1. 12 divided by 4 is 3x. 4 divided by 4 is 1. What do you see? Down there, 2 times. Factor out the common term. The common term is 3x plus 1. I still have this 2 out in front. Now, some people try to get rid of that 2 that's out in front. Do you remember from our graphing unit what a 2 out in front does to a graph? What does a number bigger than 1 out in front do to your graph? That 2 out in front is going to make a vertical stretch. There are 2 things that are coming up after we learn to factor. We will be learning to then solve this, and we will also be learning how to graph this. And that's why we can't get rid of our 2 out in front, because when we graph it, it is going to make a stretch. Okay, so that's the last one of your examples. Is that correct? So what I want to do next is look at one of your homework problems. This is problem number 1 on your homework paper. Do you see a GCF? You're going to factor out a 2. What is your, now, this A, B, and C is going to be in this form right here. So what number is in front of the x squared inside the parentheses? There's not a number. So the A is 1. The B is 1. The C is negative 6. Now, what I do is I use the margin right here. Your next step is to multiply the A times the C. So I am going to multiply 1 times negative 6, and I write it out here in the margin so it looks a little bit neater. What are the factors of negative 6? Negative 1 times 6. Negative 2 times 3. Guess you put negative 3 times 2 if you want to, and negative 6 times 1. Okay, those are all the factors of negative 6. Which of these factors are going to add up to give you a positive 1? This 2 is just going to keep hanging around out in front. This x is going to be replaced with negative 2x plus 3x, and you're still going to have the minus 6 at the end. This, replace the x because it's equal to x. If I add it up, it would be equal to 1x. The reason I did this is so I can make 2 groups of 2. What's going to factor out of this group? What's going to factor out of this group? And once again, the 2 is just hanging around in front. If I divide out an x, if I divide that out, the x's cancel and I have a minus 2. Bring the 3 out in front. The 3's cancel, leaving an x. 6 divided by 3 is negative 2. The 2 just keeps hanging out in front. What term is repeated? X minus 2. What's my second term? This is what makes the second term. The next one I want to do with you is problem number 4 because we didn't have an example like that yet. So, would you please look at problem number 4 on your homework paper next? Does it have a GCF? No. So, you multiply, well, let's go ahead and write it down. The A is 3, the B is negative 13, the C is 12. And you would probably want to try to write small. If you have naturally large handwriting, you may need to get out another piece of paper to write on. So, you multiply the A times the C, and I write that down in the margin to save a little space. And the factors of 36, it's positive 36, are the factors of 1 and 36, and 2 times 18, and 3 times 12, and 4 times 9, and 6 times 6. But I need a negative 13. I don't have any negative numbers here. But, do you remember that a negative times a negative makes a positive? If I go through and have negative 1 times negative 36, does that equal positive 36? And a negative times a negative makes a positive. So all of these could be negative, and they would still multiply together to get a positive 36. Now can you find a pair that equals to a negative 13? These two add together to equal negative 13, and they also multiply together to get 36. That's the pair I'm looking for to replace the negative 13. Why am I replacing the negative 13? I'm still going to have the 3x squared in front. I'm still going to have the 12 in the back. These replace the negative 13. The reason I needed to replace the negative 13 is because I need 2 groups of 2. I got to have 4 terms so I can make them into 2 groups of 2. What factors out of the first group? 9 and 12 divide by 3. If this is negative, I need to factor out a negative. Factor out the x, that cancels out one of those x's, that cancels out that x. This came right down. 9 divided by 3 is 3. 12 divided by negative 3 is negative 4. The reason we went through this process is to find these two numbers that when I do this step is going to give a common term. The 3x minus 4 is a common binomial. What's the next one? There is only one way to learn these steps, and that's to practice these steps. Would you please do so right now?